Welcome, everybody. My name is Robert Barton, and I am the moderator for today's webinar. I will be in the background helping out with the logistics and everything. So if you have any issues with any of the technology type problems today, please enter that information into the chat, and I'll do my best to address that. Before I turn it over to our program host and speakers, I just want to quickly ask that if you have any questions today, please enter those into the Q&A feature on Zoom, and we will moderate those at the end of today's webinar. And with that, I'm going to turn it over to our first presenter, Sean Tanger. Sean?
All right, thank you, Dr. Barden. See if I can get this right this time. Is my screen shared there?
Yes, it is.
Okay. All right. Well, thanks everyone for attending today. It's been a long process for this grant project that we worked on that was under the supervision of myself and Dr. Eric McConnell and several other of the committee members for the master's student who did most of the work, Swagata Treya. Most of those committee members are here, so I want to thank them for all their hard work. And I think we've really gotten the start of something interesting here, something that'll be useful for the forest products sector, as well as the Department of Transportation's in the various states and or economic development agencies that might work with those dealing with transportation issues. So, there was a lot of people involved in this in terms of both securing the money as well as kind of crafting the ideas, what would be valuable. You can see some of the organizations involved there. Strong Mississippi State presence. That's where the master's thesis was conducted and where I was formerly. Want to thank the industrial and systems engineering professor, Dr. Mohammed Marufazan, as well as Dr. Michael Crosby, who will be speaking with you all here once I'm done, but really, as well as the other committee members. But most importantly, I want to thank the Mississippi Forestry Commission. I had several conversations with them. We wanted to do something that was very applied and would be useful to the state of Mississippi and the surrounding southern states, and then that could potentially be utilized outside of the Southeast. And through our conversations, more and more, we kept hearing this issue of transportation problems, and they were trying to get their hands on just how big of an issue it was for our wood products sector. Now that's a big problem, and it's an even bigger problem if we include anything outside of wood products. So for this project, we decided to start small, and we're focusing strictly on road and bridge barriers as they pertain to the sawmilling sector in Mississippi. And so you can see there that the title, we want to remove any bottlenecks, or at least, initially identify those. And if we are able to improve them, what economic benefits would then be derived from those infrastructure, road and bridge barriers being removed. So the grant came from the Landscape Scale Restoration Grant Program. This is a Forest Service state and local forestry programs grant. They work hand in hand with the Southern Group of State Foresters, as well as state foresters in other parts of the country, to figure out what issues related to the state forest plan that each of the states have come up with, what projects will help address the problems identified in that state forest action plan. And so that's where the interaction with the Mississippi Forestry Commission really came into play. And it over 3 or 4 conversations, we found that of their top 2 initiatives, transportation as well as rapid response to events like hurricanes and tornadoes and things like that, was really high on the list. And so transportation kept coming up over and over. So we worked out a project that they thought would be useful that we could execute for them. So again, through multiple conversations, not just with them, but with uh, uh, several professors at the University of Southern Mississippi, as well as Josh Sullivan with local impact analytics. There were a lot of other stakeholders that provided input and feedback as we created the project and as we went through and had some preliminary results and final results. Okay, so it's a problem that many are working on from different perspectives. That shouldn't surprise anyone here. This is just going to continue to be a larger and larger problem. States have moved away, in many cases in the Southeast, from a high state tax policy, in which case those infrastructure projects are going to have to be solved through alternative methods. There's not going to be those same state monies available to the state and counties, as it were. And so we're going to have to get a little more creative and a little more precise with those solutions. You can see here, I just shared this problem is kind of ongoing. I've moved over to Arkansas for another position, but you can see here, this is a little text grab that I got from the Arkansas Forestry Association, and they've got a small bridge, a local bridge program, and they've actually doing some citizen science where they're having individuals report in on specific bridge problems that they may not have found in their own work, and actually trying to leverage those individuals who might be affected by those bridges to help provide feedback. Those state agencies aren't as large as they used to be, so just identification of which bridges need to be looked at for a comparison of which ones would be most valuable is a very important first step. So I thought that was interesting. I just got that email a couple of days ago, so I thought it would be super relevant for the program today. With that, I'm going to turn it over to our other presenter, Dr. Michael Crosby, and he's going to walk you through some of the results that we came up with and some of the geographic information systems aspects of the project and a few results.
Okay. Did it make it up there okay? I'm hoping.
Yeah, we can see it.
Awesome. I apologize first. I have two monitors, and my camera's on one and my presentation's on the other. And when you go to presentation mode, it jumps screens on me. So when you see me turn my head, it's because the information's to my right. And I didn't want to mess with it and make this worse on myself somehow. So like Dr. Tanger said, the first phase of this was trying to determine where the harvest sites were, or hypothetically where the harvest sites could be, and a sort of shortest route determination between all those potential sites and their nearest product mill. And we looked at pine mills only in Mississippi, sort of as a jumping off point. And I mean, you'll see there all the people that are involved in it from Mississippi State, where Dr. Tanger mentioned he was, and leading the project from there with Dr. McConnell and Swagat and Maroof. And I'm over at Louisiana Tech across the river. So if the others jump in at some point and you don't hear the soothing Mississippi tone, then it'll be somebody else talking and not me. But the information here is applicable over the region and really the world. But sticking to the south for the landscape restoration program, annual harvesting in the south is kind of the southeast's wood basket in a lot of ways, for pulp in particular and pine products specifically. Over this parts of 12 different states in the U.S., eastern Oklahoma and Texas, then what I would consider the southeast proper, with Arkansas, Louisiana, Tennessee, Mississippi, Alabama, Georgia, Florida, the Carolinas, and Virginia. About 300 million tons a year are harvested, and that's the last year we had the data available for in 2022. Specific to Mississippi, about a tenth of that, 30 million tons a year, and over half is pine, or pine saw timber specifically. So it, like Dr. Tanger mentioned, with the infrastructure and in any state, but particularly in a state like Mississippi, which is where I spent about the first 30 years of my life. Infrastructure can be a problem, and we've probably, regardless of where you live, you have memes of potholes and trying to navigate those on roads. And as you do that, transportation and the logging industry is somewhere in the neighborhood of half or 40% of logging costs over a larger scale. In Mississippi, it's a little more. The gate value of timber in 2022 was $1.3 billion, and you see about 53% of that was the harvest and haul. And when you have a state that has something like 3,000 posted bridges, so some weight restriction at some level, that could become a problem when you have to cross all the creeks, streams, rivers, and that kind of thing to get it from the woods to its processing facility. So the goal here, and you're looking at product locations, the goal here is to find the weight restricted bridges and analyze how that impacts the transportation of timber to the mill. And what again we're looking for is just pine. If you involve all product classes and all mill locations, and we kind of wanted to start at a sort of an important point with pine saw timber and a simpler way to analyze it. One product go into one locate or one series of locations. And the data comes from really, I would say everywhere, but it comes from a lot of locations. We used FIA data over a 10-year period, and that the idea there was to get 2 whole cycles of FIA data for the state. And those were our harvest locations. So the plots that were coded as having been harvested are the ones that we selected for that. And from RISI and the Mississippi Forestry Commission, we got the the sawmill locations, and then the bridge and road data. Primarily, the bridge data here came from a lot of different places: the Mississippi Department of Transportation, the Office of State Aid Roads, the Federal Highway Transportation Commission, and the Census Bureau for some early looks at road networks. And in particular, I'll mention one specifically in a minute. What we used here was Network Analyst. It's a tool in the Esri ArcGIS Pro software that lets you do analysis between nodes or from 2 locations. And the network here is going to be our road network. And that's how we got to our sort of shortest travel distance between the woods and the mill. And then later, and this really has to do with second plus stage of the project, is using a Python and Garobi to optimize what you do in those mills, or when you can't get directly to those mills, multiple loads and things like that. So that'll be the focus of a little more down the road, but I kind of have a teaser slide at the end, so I wanted to get that in now. So our harvest sites, we had 46 FIA plots that had been coded as harvest, and you see them in green there on the map on the left. And we have 32 pine sawmills in Mississippi. So what happened with the sawmills is they have geocoded locations for those, and we buffered them all, or buffered them all at a 50-mile radius and dissolved the polygons, and that kind of became our study area. And the idea there was trying to pick a distance that would simulate our wood basket for each mill. So a 50-mile radius between all of them. It puts us in parts of Louisiana, extreme southeastern Arkansas, Alabama, and Tennessee. And eastern Louisiana, and then parts of the Florida parishes. Sorry, I'm sitting in Louisiana forgetting about it. So we needed all the FIA plots that would fit within that buffer. If you've seen yet, I think Dr. Barden sent yesterday, there are 2 videos that accompanied the presentation. One kind of takes you through the FIA methodology in R. So using the R FIA package to take the data from the raw data from Data Mart, get it processed and ready to put in the GIS software. And the other video is how to get basically all the methodology done to do network analysis. And the reasons those exist, I think one video is about 40 minutes and one's about 30. So it was going to take us well beyond the hour to go through all of those things. For the sake of expediency and posterity, there's videos there for you. So what we found after we got our study area is we extracted all of the mills and all the FIA plots and all the bridges, and the roads that we were going to be looking at, or the area of the roads we would be looking at, and found something interesting. So there's almost 3,000 bridges you see in the table there, 2,700 some odd bridges. There were 269 that are closed. You may not go across this. And then there are almost 700 that have posted weight limits. So the idea there is bridge integrity gets rough and they'll post it, and you can't go across this bridge if you weigh more than 25 tons, for example. That leaves us with 962 of the bridges in the whole state out of 2,700 that we could get reliable information on. So it's not that the information doesn't exist, it's that it was not in any of the databases that we could find. And that's not the fault of anybody, really. It's just, the database hadn't been updated, or the weights were incomplete. And we'd need a little bit more robust data set to really drill down within the state and certainly within the region. So there, on the right, you see the closed and posted with weight limit bridges in our study area. So this is going to be our impediment to travel, or our bottleneck, if you will. So we have 2 scenarios here that we looked at. We're looking at gross vehicle weight of 84,000 pounds, because see me look, it's changed. So for the sake of this study, it was 84,000 pounds or 42 tons was our load limit for our log trucks. In July of 2023, so last summer, that increased to 43 tons if you have a permit for that weight. So because SWGOT was working before then, we had to start with what was allowed at the time, and obviously if you project this forward, it would impact your load limits maybe. So you run the network analyst, and from the woods to the mill, how many miles is it? How much time does it take? That kind of thing. Then we use our bridges as an impediment. So if we're posted below 42 tons, you can't go that way anymore. So we restrict those bridges, and it reroutes our trucks, and that has a different mileage traveled. So what we had were 129 shortest optimal routes, and 30 of those happen to have had restricted bridges, and 13 of those had viable alternative routes. And what we mean there is there were routes that didn't go beyond 57 miles from the mill. James Shannon works in Mississippi State Extension Service, is working on his PhD now. He's done a survey, and it was kind of the average max distance that people were willing to go in his survey in Mississippi was 57 miles. So if our alternate route took us beyond 57 miles, we canceled it. Again, just as a way to have something to start with. Not that it necessarily, they wouldn't truck at 60 miles, but in our scenario here, they wouldn't. So we're whittling down now our data set substantially. But of those affected in alternate routes. On the right there, you see the red. Our average and total distances go up, which if you can't go through, you have to go around. You've increased the mileage that you have to haul something. And if you calculate per mile costs of things, mileage goes up, dollars go up. And here are our shortest optimal distances. The average was about 30 miles, 31 there. The alternative routes, the average goes up to about 35 and a half miles. So we've got on average about an 18% increase in our haul distances between harvest locations and mills because of the bridge outage, or the bridge is being posted. So you see there sort of the mileage varies, no pun intended, between harvest locations and mills. Depending upon where it is and how many bridges, and in some cases there were more than one, it may not be able to go its second shortest distance. I mean, we don't necessarily know that, but the idea there is that if it couldn't go 10 miles, then in some cases, you see there, the site 13 to mill 11, for example, it was about 18 miles to start with. And instead of 18 miles, now it's about 31, I think it was, for that one in particular. And they all go up. This is, in some cases, it's not going a block over and coming back. It's really including some moving from the trucks here. Our costs, we have our non-restricted and restricted costs, and we did this per ton. And you'll see the changes there, and the percent change specifically at the bottom is our increase in hauling premiums. We're getting close to $80,000. That'd be right there. Yeah, one would be $1 million. Which maybe for just offhand doesn't seem like a lot of money, but we're looking at 30 mills in one state and 13 routes. This isn't all the bridges, all the harvest sites, and that kind of thing. So we have also have an increase in truckloads, and there's again kind of a teaser slide in a minute with the optimization is what the mills are demanding, or what the demand of these mills is, and what it takes to meet that demand. And so the next stage will be, are we going to use half loaded trucks? I mean, the answer is no, but if you try something like that, what's the cost increase going to be? The gas prices aren't really going down for having to haul more distance. So our variable cost increase there is about $4 million. And fixed costs aren't going to change, but our total cost is going to go up for all mills, all distances. So the idea is that if you're increasing hauling distances, this may affect, the downstream effects here may be insurance rates. And a lot of the South, those are fairly high. And if you're driving more distance, you have more risk. You are probably going to be going down some roads that may be more curvy, or what have you. The likelihood for accident will increase. And there's part of your variable cost increase. Never mind just the absolute value of mileage that goes up. So every mile costs you more money. And arrows. So our impact on mills there, of the 30 mills, we had 11 that had more, or an increase in transportation cost. A lot of them were less than $1, or about $1, and then you'll see some that have about a $3.50 per ton increase. So if you're hauling 30 tons, let's say, or 42 tons, if you think about it like that, times $3.50, X number of truckloads a day, it starts to stack up fairly quickly. And that percentage change there, when you see that the trend in the percentage change, or it's not a trend, but the differences in the percent change, again, has to do with where that mill is located and what the road network looks like between it. And there's, in the video, you'll see some examples where it's kind of zoomed in and shows you how that plays out in real time with the analysis. And in here, there isn't a good screenshot that we can pull out and put in that sort of would illustrate this a little better. It worked better in the video version. So please check that out. So can the demand be met of these mills? Generally speaking, yes. And this is where we're starting to look at fulfilling the demand or the percentage demand for these different sawmills. And in some cases there, for some of these mills, you see where they're only hitting about half of that demand, regardless, I guess I would say. But generally speaking, they can get what the mills need, but it's costing extra truckloads. And again, this is going to be a result of having to haul the wood or haul the timber a greater distance. Vehicle weight is the big impact. About 20 years ago now, there was a study in Mississippi, and where they looked at lowering the vehicle weights would increase the trucking cost about 4%. In another scenario, about a 2.5% increase in trucks were below that limit. In Georgia, kind of again keeping it in the South, fewer than 5% of the log trucks were underloaded by more than 10%. So there's the sort of the hook there is, could you underload a truck so that you could go across a posted bridge? Sure, but I don't imagine very many people are going to do that. And it's, again, this is speaking as somebody with no log trucks, but I'm the loggers that I've talked to, they're going to tell you no. And the mills too. I mean, you wouldn't want the cost increase from running more trucks that are underloaded. So sort of what we went through here, with about a quarter of our harvest sites had posted bridges. And from the beginning, right, we've got about 20%, a little more than about 20% of the bridges that we have data on. So we were limited by the availability of the data. We sampled a relatively small area for harvest sites. We're looking at basically Mississippi. Even the study area goes over, but some of the state gets missed out. And we made an assumption about the 57-mile limit for harvesting haul distances. But in that, 37% of the routes had increased costs. The average is about 30 cents a ton, but again, we had some that were $3+. And that transportation cost, and obviously we're, if one were to consider insurance premiums, fuel costs, repair costs, that kind of thing, the maintenance cost of the vehicles, that's going to mess with your transportation costs and tie back to your vehicle weight. The idea here that we had was which mill or which mills, plural, would need the most wood, that have the most ready access to harvest sites. So then we could figure out what the priority would be for maintenance and upgrades. And Dr. Tanger at the beginning showed that RDOT, the Arkansas DOT call there, that's kind of the thing that they're looking for. That if we've got 500 bridges that need repaired and we have money to repair 10 to make it so that it doesn't impact the hauling logs or whatever. I mean, fuel, fertilizer, all those things. And a lot of ag goes on in the South. What 10 bridges? So really the difference in something like that and what we've done here is considering multiple vehicles, not just log trucks, but we're ultimately dealing with weights. We're dealing with the same road network. We're dealing with the same bridges. So, all things considered, which bridges should we fix? Or just in terms of the forestry sector, which bridges should we fix? They're likely to be very close as I think about it. And what might the local economic impact be? The number of jobs in Mississippi in the forestry sector, tens of thousands of jobs in $1 billion+ industry just in Mississippi. And again, most southern states I think are similar to that. Some of these smaller communities, independent log truck companies, that kind of thing. What is it going to mean to those guys to have bridges that they can't access to pull the logs to the mills? And then what is their exposure to accident being out there on those networks, on the roads for greater distances, greater parts of the day, that kind of thing. But that's sort of that would be further downstream, looking at that kind of thing. But again, what we really are after here is where are the bridges that need work, or where are the bridges we can't use along these road networks? What impact did it have getting timber from the woods to the sawmills? And going forward, we'll look at trying to optimize what that means. Is it more truckloads? Is it worth looking at? Maybe you don't go to this mill, you go to a different one. All of those kinds of things. And with that, we've got you a little over an hour of extra material there. We've got plenty of time for questions, and this was very much by design, so that we kind of want to get that conversation started and those questions going for this project and for the seminars that'll come. But thank you guys very much.
Thanks, Michael. Yeah, while people percolate on that and see if they want to put any questions in the Q&A, let's go over just a few points. I think you and I have talked about these already. Let me make sure my video's on, sorry. One was we found the kind of strange thing initially that once we overlaid the bridge impediments data, sometimes with network analysts, the scenario two, as it were, the one with the impediments, was actually routing a shorter distance than the original. When there was no impediments. What was driving that, and how do you deal with that in GIS?
Oh man, I'm sorry. I meant to mention that. That may not be in that video. So the way that network analyst works, and if you build your own road network, there are things that you'll need. You'll need speeds, the speed limit on the roads, the direction of travel, hierarchy, county road, state highway, interstate, federal highways, that kind of thing. And you'll need a hierarchy still. Is it a bridge? Does the bridge go over or under, that kind of thing? We used ArcGIS Online's road network. If you have access to Esri products and you can get ArcGIS Online, you should be able to use this as well. If not, there are several available that you can find. I probably shouldn't say this because it's getting recorded, and I'm going to say don't quote me on this, but we're filming it. OpenStreetMap may have one too. But what you do when you set up Network Analyst is you'll set up a bunch of conditions. And after we set up the number of axles, the weight limits, all of those things, you don't use sidewalks, that kind of stuff. We ran them, and like Dr. Tanger said, we found that some of them were shorter because it was putting them on what ultimately would have been weight restricted roads. It would use the interstate that you can't use, or it would use roads that maybe had a weight limit because you were forcing it to use a different route and it was picking one. So there's a hierarchy. So we unchecked hierarchy, so it wouldn't go to the best road. Like that, ultimately, your first choice is like your GPS in your car. Usually, it's either shortest route or least amount of time. And for us, it's shortest route. Uh, Outside of that, it will start to try to use road hierarchy. So it would get on the interstate, or it would try to get on the Natchez Trace, or something to that effect. So you can restrict the Natchez Trace and interstates, but you could also use this hierarchy to tell it to stop doing that. And simplifying the simplified geometry, I think, is what the other thing was that we unchecked. Um, just to, again, basically not to let it do what it wanted to do what we hoped it would do, what it's supposed to do. Um, and for us driving, like I have a GMC Canyon. I pretty much drive it anywhere. But if I have a 42-ton log truck doing commerce things in the state, they can't get on the interstates. So that was I guess it's good that it happened. Otherwise, we would never have noticed the oversight. But Swagat was presenting to us, and he's made the comment something like, interestingly, it's shorter to have a bridge out. And everybody kind of, my camera's usually not on, but everybody's head kind of turned. What? So we had to do some digging there.
Yeah.
But that's the trick there, is making sure that the hierarchy unchecked, so it doesn't prioritize something that it's going to keep shortest distance, so it'll use an interstate. You effectively tell it not to.
Yeah, I bring that up for those specifics, but further to remind the audience and anybody that watched the recording, you really need to go in and troubleshoot the network once you build it, because there are these little wrinkles that if you're looking at a statewide effect, maybe it's not a huge deal, but if you're looking at a particular county wants to get a handle on the bridge situation and how it's affecting things, you need to really scrutinize that, to those points that Dr. Crosby mentioned. Um, Mike, one other thing, and we talked about this too, you know, based on the filtering that we did, and that's on the recording that I did for the RFIA data. We pared down the sites quite a bit because we wanted them to be operationally realistic. Typically, a logger is not going to harvest on an acre where they can't get at least 26 tons per acre, and they'd prefer more. There are quite a few, looking at the FIA data, there are quite a few over that 10-year period sites where there's not 26 tons, but they were harvested. So some of that may be sampling problems, some of it may be uh, a logger was desperate, and they took the wood and just maybe didn't make as much money because they needed cash flow for the week. Either way, uh, one of the criticisms for what we did, and rightly so, was we just don't have enough harvest sites. Now, for the demand conditions, we overcame that by doing small area estimation expansion and basically made each site 6,000 acres. And so that way our mills get filled by the few harvest sites that we have. But as those listening probably know, most harvests don't occur on 6,000 acre properties. Most of them are somewhere in the neighborhood of 50 to 200. That's the predominant ones from what we hear anecdotally, and then some published empirical evidence. So one thing you can do is not filter down the harvest sites as strongly as we did. This would give you far more sites. And for this particular project, you're not as worried about um, the individual site characteristics as long as it's the right species, so much as you are identifying which bridges are pretty important to getting to those mill sites. And so if you only have one harvest site, but there's 3 outed bridges in that county, and you only have one harvest site in the county, you might be missing out on some dynamicism that you'd get if you would, use, say, 15 harvest sites. And so one thing I think, Dr. Crosby, you mentioned we can do is, even within network analyst, you can mimic and duplicate harvest sites and place them in different places. Is that correct?
Right. Yeah. Um, I think what we talked about was if it came down to it, you could do the highly scientific method of just making up points and putting them places. Which works, right? If it's pine forest you're looking at, you can identify all the pine forests and randomly put a point somewhere in that forest, and you can even have it pick. If somebody might contract with meal X and they've got to deliver so much wood, but alternatively, if you wanted to say I've got so much biomass here, where should I take it? Based on these road conditions, you put all the impediments in, put all the mills in, and let it route to the shortest one. And you can run many points at once. And the other way is one mill versus 15 harvest locations, and obviously you're going to have seasonal impacts, like how many work days do I have in the winter, kind of thing. So a super sandy site that's dry enough in December to harvest, maybe that's the one that you go for because there aren't impediments from your other site that you're going to have to drive 10 more miles for. All of a sudden this one's better now, and that might work with marginal conditions. And there were a lot of different things that you can do, and I think at the end of that video we did one of those where there were a bunch of locations that went to a meal. But if not, and people are interested, I like making stuff up. I do it in class all the time, so I'd be happy to put that together.
Well, yeah, I just wanted to make that point to everybody. The bridges we had to limit because we didn't have information. Now we could hypothesize and say, well, the bridges we do have information are normally, there's a normal distribution, and we'll apply that to all those other bridges. We could do the same thing for the harvest sites. So if you want to get a clearer picture of, what could be, um, then those two methods are, ways that you can go. Scientifically, a little more scientifically valid way of adding those. But if you're just looking for important impediments, it really doesn't matter, right? If those sites are legit real sites or not. You're just trying to get an idea of what that spider web looks like, right, in your particular area. So don't get too hung up on that if you try to want to replicate these results for your own purposes. And I did want to say that as well. If you do want to try to go down this path and create some of the stuff like we've recorded for you, the grant is finished up at the middle of the year. But we anticipate trying to move this forward and do things in the future as well to build upon what we've created already. And so if you're interested in some technical support, within reason, we're happy to help you out to that end. So it even as one of the major professors, the overall process putting everything together was pretty daunting. The members that we have on the team are very diverse. Dr. Crosby has expertise I don't have. Dr. Marufason has expertise I don't have, et cetera. And so it really was kind of drawing in all these different expertise areas to solve a complex problem. So, if you're intimidated by it, trust me, you're in company, because I'm intimidated by it. So we're happy to help where we can, and we'd really like for people to adopt this and try to provide these tools for those that don't have 2 years to work out how to solve this stuff. We do have that time, and so if we can make it easily accessible and provide you guys with some troubleshooting help, and then we can get more people working on the problem, that's how we're going to be able to solve some of this stuff. So I think that's all from me in terms of other issues. We'll talk more about the demand side of things in the next presentation when we go over some of the optimization results and how those models work, and some of the uh, not hypotheticals, but some of the assumptions we had to build in order to make things work. Let's see, do we have any questions here? All right, no questions. Dr. Crosby, anybody else on the team have any points they want to hit before we finish up here? Okay. Well, that's all I have. Dr. Barden, did you need to close anything out for us?
Uh, First of all, I'd like to thank you guys for taking the time to put the presentation together and share these resources and everything. I do want to remind folks that the videos that were referenced in today's webinar, as well as the other resources, are on the portal. I posted the link there in the chat for you. It is actually the same link that you joined the webinar with today. And we'll also get copies of slides and stuff posted up there here shortly and everything. Unless you guys have something else, or if there's any last minute questions that may have popped up or something, that should conclude today's webinar.
All right. Well, thank you.
Thank y'all.